Hello, my name is Kriston Phan. I'm from Baltic STEM High School, and today I'll be presenting about investigating potential carcinogenic effects of exposure to Teflon and ceramic nonstick pans with S. cerevisiae. So, for some background information, majority of the people in households today own some sort of cookware, for example, pots, rice, cookers, skillets, and many more. One of the more popular kitchen cookware people own are frying pans, specifically stainless steel pans. However, over the years, many people have found that these pans cause lots of problems when using to cook. For example, foods end up getting stuck, causing it to be more harder to work with and making it such a hassle to wash off. Because of this, many manufacturers and companies take note of this and come up with an alternative, for example, non-stick frying pans. Many of us should have some sort of non-stick frying pan in our household. They make cooking way easier, allowing foods to slide off and on with ease. This is because it's known to be made out of a synthetic substance placed on top of these pans. Additionally, they have become widely popular due to their benefits in cooking. One of the substances that these pans are made from is Teflon. So, what is Teflon? Teflon is a name brand for a synthetic polymer called PTFE or polytetrafluoroethylene, and they actually contain a chemical called PFOAs. PFOAs were found or known to be forever chemicals because they remain in your bodies up to multiple years. This is due to their strong bonds making Teflon stable and resistant to degradation. Additionally, a study done in 2006 by Williams showed that PFOAs are linked to cause cancers and other health complications. Another study shows that when Teflon pans start to exceed higher temperatures, it causes these pans to wear out faster, causing the coatings to come off and make its way into the human body. For example, a study done by Abeluzes tested out three different manufactured Teflon pans at different temperatures and measured how much mass it lost from each pan. And it can be seen that the highest temperature being in the pink line at 350 degrees Celsius caused more wear and castings to come off. Because of the studies, it emerged two different pans, for example, alternatives like ceramic green pans. So these ceramic green pans are seen to not contain any sort of PFOAs, making people view this as a safer alternative. This is because it's made out of a silicone and silica polymer being applied to the top of these metal pans. However, studies have found that scraping these types of pans released a significant amount of titanium dioxide and silicon dioxide nanoparticles, and these types of nanoparticles can cause carcinogenic effects based on a study done in 2020. But how do we determine these carcinogenic effects happening if we were to use yeast? So, to back up a little before talking about yeast, we have to identify how cancer is formed in cells. Cancerous growth is defined by when cells start dividing rapidly and more abnormally. For this research, I'll be focusing on replicative aging in yeast. Replicative aging is the number of daughter cells a mother cell produces before it stops producing and dies due to apoptosis. So for the model organism I'm using, I'll be using Saccharomyces cerevisiae, also known as yeast. So yeast is a popular model organism used to study aging and cancer. They have similar pathways with humans. It is non-pathogenic, simple, fast-growing, also really cheap, and it's easier to observe aging and lifespans compared to humans where we live up to 0 to maybe almost 100 years. And yeast is also unicellular. So, comparing yeast and human similarities, this figure further explains how yeast can be used as a model organism for human diseases, specifically how genes can be conserved from humans to yeast. If a human protein has a yeast counterpart, the yeast protein can be used to study and its environment, and its function can be compared with the one in human cells, or the human gene can be cloned and expressed in yeast in order to be studied in a neutral environment. In general, the genes responsible for cell division, aging, and death are all conserved from yeast to humans. Because of this, unicellular yeast such as Saccharomyces cerevisiae is an excellent model organism to study those factors without any other compound factors which would have been present in bigger organisms or multicellular organisms. So, this is an example of how cell division and replication works. It begins with a parent cell, then goes then when the cell goes through the G1 phase, it decides whether or not to continue, then replicates the original parent cell DNA, and then finally splits off into two daughter cells and then repeats the process. However, when looking at cancerous growth in cells, we are looking if there's any abnormal growth going on, specifically at cell proliferation. Cell proliferation is the increase in cell number due to the cell growth and division, which is tightly regulated process driven by cell cycle. The cell cycle consists of several phases like the G1 phase, the S phase, G2, and N phase. And the M phase where it copies the DNA and then divides into to create the daughter cells. For example, in this figure shown, it shows a normal cell and a damaged cell. So for the healthy tissue, as you can see, when there's a damaged cell, something called apoptosis, which is just a process of programmed cell death, which is just a controlled and orderly way for a cell to self-destruct, so our cells can be still healthy, and then cell death would happen and then our cells are fine. However, when it comes to abnormal growth, when the damaged cells continues on, it can mess up the cell cycle, um, inducing or like upregulating cell growth, making it into uncontrolled growth in the cell. So, for my research, or where there's gaps in the research, although there has been studies done on health complications of nonstick pans, none of them have been done on comparing the two and its exposure to using the model organism Saccharomyces cerevisiae or yeast. To address the gap, I'll be using a series of methods to look at cell replication, and I'll be testing to see if Teflon and ceramic coatings causes yeast cells to replicate more over time, indicating a sign of cancer that can be determined if Teflon or ceramic is more safe to use. My hypothesis is that exposure to higher residues or concentrations of Teflon and ceramic coatings can lead to a higher increase in cell replication within yeast caused by mutations and sped up aging, showing a sign of possible cancer formation. So, these are a list of my methods, and I'll go into them a little more deeper and one by one. So for my first step, I would gather two worn out nonstick pans, one of them being ceramic green pan and one of them being a Teflon pan. And then what I would do is I would begin scraping them off with a razor blade. And to the reason why I'm using a razor blade is because I want to mimic the sharp objects that we use on these pans, and then we can like gather the residues into a tiny container to use later on. Then I'll be streaking yeast, and then I'll be adding it to my liquid media called YPD. So this is a growth medium that helps yeast grow. It provides nutrients for yeast, including a carbon source. It's made of dextrose, which is a glucose, and then amino acids from peptone, and then a water soluble compound, which is the yeast extract. Then I'll use the Teflon and ceramic scrapings, and then I'll make a stock solution out of each one of them. And then I'll add each one of these concentrations into my YPD media. So the reason why I chose these concentrations was because 2.1 was actually found in our blood concentration, 32.9 was found in workers working near polluted waters, and 1130 was found in people drinking the polluted water. And then for my control, I would be using nothing, so I can use to compare my other medias that I have concentrations with. So the next step is I'll be placing each one of these concentrations, and I'll be measuring its optical density over time. So what the optical density test is that it measures the amount of light that passes through the media using absorbance and transmission percent. Absorbance measures how much light is being absorbed and blocked by the solutions from scattered cells replicating over time. Transmission is measured by the amount of light that passes through. This all depends on how cloudy or clear the solution is. So, for example, if my solution for my liquid media is more cloudy, the light will be blocked off and less light will be able to pass through. If the solution was less cloudy, less light will be blocked off and more light will be able to pass through. The relationship for this is indirect. Then I'll be doing a data analysis which compares the data with each other, and then I'll be doing a statistics test, calculating p-values and creating error bars for them, and then I'll take my data and interpret it. So for the first one, I measured it over 8 days. So absorbance for these concentrations would have ended up about having the same starting value near zero, showing that there wasn't a lot of light being blocked, indicating that the solution hasn't been cloudy and none of the cells have been replicated yet. Over time, during day 2, you can start to see they increase. Then day 3, they decrease, again showing that it got more clear, and then increased again around day 8. And then surprisingly, the concentration with 32.9 microliters ended up having a greater change in absorbance compared to the highest concentration, and 2.1 and 1130 had the lowest change compared to the control as well. Excuse me. So for this one, this is the ceramic concentrations, and it was seen that 1130 microliters concentration started off with a much more higher absorbance, then later increased, but not as much compared to the other concentrations. And then for this one, comparing the transmission, it's just an indirect relationship between the absorbance rate. So whatever the absorbance rate is, we would take that and it would be the indirect relationship. So as we can see, the one with the least amount of concentration should have been more light passing through compared to the other higher concentrations. And compared to the control, actually they had the same replication um, and same results as our original. And then for our ceramic concentration transmission, there were different results, and we can see the highest concentration actually had less light passing through compared to the other lower concentrations. So, interpretation of my results. So, my results, we can see that Teflon, the highest concentration, actually had the second highest replication. And then for the second highest concentration, Teflon and ceramic replicated the most and least. And then for our lowest concentration, it had the lowest replication. And then for the lowest concentration for ceramic, it replicated the most. So there were a lot of limitations with my study or my research data, and it could be seen that data wasn't as consistent nor significant. There could have been a possible error with the spectrophotometer causing data to have some sort of error, and I couldn't have observed if yeast had died in the cell during the replication, because if I were to observe if yeast have died in my media, it would explain why it was more cloudy compared to not. And I did not measure ROS or reactive oxygen species whatsoever, measuring because if I were to measure ROS, I could have used a hydrogen peroxide assay, seeing that the cells were exposed to, which would also explain why the cells would have replicated more than it should. And I did not use other methods as well. These are my references, and thank you for listening.